Welcome back, puppies, and it's round 2 of finding the equation of tangent lines. So you may remember that before, when we would find the equation of tangent lines, we would maybe approximate the value of the derivative, and we would use that for the slope of our tangent line. And of course, that's the right approach, except for the fact that we were approximating the value of the derivative. Now, with our fancy new derivative rules, we can calculate the derivative exactly, and that means that we're going to be able to find tangent lines maybe more easily than before. So we're going to get started.
Is someone in here? Dude, what the hell?
Oh, hey, Frenchy Poo.
What are you doing here?
Dude, I'm just making a video.
Dude, didn't you hear me taking a shower?
Oh, I just kind of walked right in.
I locked the door.
Ooh, awkward. Alright guys, well, someone's being a little sensitive, so let's go ahead and make this video somewhere else. Some people. No pleasing anybody. Alright. So dudes, here's the thing. We're finding the equations of these tangent lines using our fancy rules. And so let's get started with this first example. We're going to find the tangent line to this crazy equation at x equals 2. So of course, first thing we want to do is get a point and a slope. Those are the two things you need for any line. And to get our point, we are simply going to plug in the given x value into this equation right here. So dogs, if we plug in x equals 2 into the function, then we get f of 2 equals, and then you just want to plug this in yourself, make sure you get the right thing, but this first part is 12, and the second part is 14, and this third part is plus 5, and so the whole thing ends up being 3. And that means that we have this point, which is 2, 3, and that's going to be the main point that our tangent line goes through. So, let's get some more space here. We've got a point, but now we want a slope. And remember, slope comes from the derivative. So the first thing we're going to do to find the slope is take the derivative, and it's going to look like this. 3x squared becomes 3 times 2x, minus 7x becomes minus 7, and the 5 just becomes 0. Simplify this crap, and we get 6x minus 7. And now that's the formula for the derivative. But dudes, remember, this really is the function that tells us the slope at the point of, whatever this function is. So if you pick a particular x value, and in fact we already have, x equals 2, then what f prime of x tells you is the slope of the tangent line to the original function at the point 2. So this is just a complicated way of saying if you want the slope of the tangent line, all you have to do is plug 2 into the derivative formula. The slope is going to be the derivative evaluated at that point you're looking for. So putting in 2 into the function, you get 12 minus 7, which is 5. And now let's give ourselves some more room and actually write down what the equation of the final line is. So dudes, for this final equation of the line, what we want is something that is going to be in the line form. So y equals mx plus b, and we already know m. We found that using the derivative, so our equation is going to look like 5x plus b. We just don't know what the value of b is yet. But dudes, not so hard to find, because that's why God invented points. We know what a point on the line should be, so we can actually plug that in. Change the y value to 3, change the x value to 2, and that lets us solve for b. So we've got 3, we subtract that 10 on both sides. 3 minus 10 is negative 7. And that's what our b should be. So our b should be negative 7. Our final equation is 5x minus 7. And so dudes, if you want to check your answer for something like this, it's actually pretty easy. As long as you're sure that the derivative is right, you know that the slope should be 5, and indeed it is. And this is the line that should pass through the point 2, 3. And in fact it does. If you plug in 2 for x, you get out 3 for y. So all of this tells us that we did the tangent line correctly. Now, I'm going to do one more example for you, and this example is going to be an example where we approximate values using the tangent line. So here's what we're looking for. We're trying to approximate the square root of 5 as best we can. And you guys remember, you've seen problems like this before. If you're supposed to approximate the value of a function, then that's where you use the tangent line to do that approximation. So check it out, puppies. If we're approximating the square root of 5, that's the same thing as saying that we want to approximate f of 5. And if we want to approximate f of 5, then we want to use a nearby point that works out nicely. So we're going to approximate f of 5 using a point where we can actually take the square root easily, and it should be something that's close to 5. So we're going to use x equals 4. 4 is pretty close to 5, and it's something that we can easily take the square root of. We can plug it in the original function easily. So just like before, what we're going to do now is find the tangent line at the point 4. And let's write this down. We're going to find the tangent line to f of x at x equals 4. And one more time, dudes, the reason why we're picking x equals 4 is because of two reasons. First, 4 is close by to 5. And then secondly, 4 is something that we can plug into the original equation, square root of x, and then get an easy y value. Taking the square root of 4 is easy, taking the square root of 5, not so much. So we want to find the tangent line, and to do this, we're going to need a point. We know that our x value is going to be 4. Plugging 4 into the square root function, well, the square root of 4 is 2, so that's our y value. Our point is 4, 2. No big deal. Now the next thing we need to do is calculate the slope, and in order to do that, we need the derivative. So first thing that we want to do is find the derivative. The derivative of this function is going to be the derivative of the square root function. And of course, we want to rewrite the square root function as a power function. So we're going to write it as the derivative of x to the 1/2. Oh God. Okay, I'm fine. All right, now what's the derivative of x to the 1/2? You bring down the 1/2 and you make it x to the minus 1/2. And one thing that you can always do is take x to the minus 1/2 and rewrite that as 1 over square root of x. Or maybe if I go a little more slowly, x to the minus 1/2 is 1 over x to the plus 1/2. And now we can change x to the plus 1/2 back to square root of x. Now, when we did derivatives of square root of x previously, I didn't bother to rewrite it in this form. But the reason why I'm doing that now is because it's going to make it a lot easier to plug in the number 4. Because dudes, we found the derivative function, but in order to find the slope of our tangent line, we actually need to find the derivative function evaluated at that x value that we chose in the beginning. All of the stuff that we're doing right now is happening at the x value 4. So we need to plug the x value 4 into our derivative. And if we do that, well, that's plugging 4 into this equation right here. So 1/2, 1 over the square root of 4. Square root of 4 is 1/2. And 1/2 times 1/2 is 1/4. So dudes, we figured out two things. By plugging in x equals 4 into the original function, we found that the point we care about is 4, 2. And then the second thing is by taking the derivative and then still plugging in the same x value, which is 4, we found that the slope we care about is 1/4. So we're going to have y equals mx plus b, and we already know what m is. It's going to be the slope we found with our derivative, people. That's what m is. Pick up the pace. All right, now we're going to solve for b by plugging in our point. Our y value was 2. Our x value is 4. And 1/4 times 4 is just 1. So on the left, we get 2 minus 1. So b is just 1. Plugging 1 back in for b, our tangent line is 1/4 x plus 1. And now, finally, dudes, we can do step 2. Remember, whenever you're approximating a function, there are two steps. The first step is find the tangent line, and then the second step is to use the tangent line to figure out your approximation. So let's go back and review what we had. We had this goal of approximating the square root of 5, which is the same thing as approximating f of 5. We used this nearby point where we could find the value of the slope and the original function pretty easily. But now that we actually found the tangent line at this point, that means we want to go back and plug 5 in for our x value in the tangent line. So we found the tangent line at the good point, but now we want to plug the bad point into the tangent line. So this is our tangent line, and the answer that we're looking for, the approximation, is 1/4. We use our bad value for x, and this is 5/4 plus 1, and if you want to, you can make this 9/4. And so in the end, dudes, we calculated the tangent line and used this to show that the square root of 5 is approximately, although of course not equal to, 9/4. Hope that rocks. Catch you dudes on the flip side.